So what we've done so far in this section is solve quadratic equations by using the factors. So we've taken the equations, put them in standard form, factored them, and then used those factors to solve the equation. In this lesson, what we're going to look at is a couple scenarios that appear in equations where there are some patterns that happen every time, and because of the way that these patterns happen, if we learn to recognize these patterns, we can find the factors without actually having to do any arithmetic or very limited arithmetic and having to do very limited work if we can learn to see these patterns. But to first do that, we need to make sure we discuss what a perfect square is and what a conjugate is. Perfect squares are and what conjugates are. So first of all, perfect squares. This is an example of a perfect square. 2x plus 4 squared would just be 2x plus 4 times 2x plus 4. Now we can simplify this, we can distribute. That's 4x squared, 8x, 8x, and 16. When we combine our like terms, we get 16x plus 16 and 4x squared. Now using this, I want to show you the patterns that happen when we have the product of perfect square binomials. So first of all, I want you to notice that our first term is the square of this term. 2x squared is 4x squared. The last term is the square of the second term. 4 times 4 is 16. And then the middle term, so let me switch the color of that. The middle term came from the 8 and the 8. Well, they're going to be the same every time because 2 and 4, we have 2 times 4, and then we also have 4 times 2, which is the same thing. Because that will always be the same, this middle term comes from multiplying these together and doubling it. So what we could say is that b equals 2 times these two terms. So b equals 2 times times the 2 times the 4. So we take the two terms from in here, multiply those together, multiply that, so multiply those together and then multiply that by 2. So 2 times 4 is 8 times 2 is 16. And that's where we get that middle term from. So I know this kind of looks like a mess now, but we'll look at some examples to hopefully clear that up. All right, so that's perfect squares. All right, now let's look at what conjugates are. So conjugates are very similar to perfect squares. The difference occurs here. So this is plus 11, this is minus 11. So the 3x, those are the same, but that second term is different, and that's what makes these conjugates. So let's look at what happens when we distribute here. 9x squared, negative 33x, positive 33x, and negative 121. We combine those, they actually cancel, and we just get 9x squared minus 121. So let's look at the patterns that happened here. First of all, we have 9x squared, that is that first term squared, and then we have as well 121. So I know it's minus, but let's just focus on the 121 right now. It's 11 squared. The reason that it's negative is because we have a positive times a negative. Now, the most important part of this and what sets this apart from the perfect squares and the way that we can recognize this is that it has no b term. Here, this middle term, it canceled out. And the reason it canceled out is because one of these is positive and one of these is 11. And since our absolute values are the same, well, something plus its opposite is 0, so that middle term cancels out. So that's what we're looking for when we're dealing with conjugates. Now, the way that we're going to apply this is in reverse of what we just looked at. So again, in factoring, we want to take the equation and find the factors that it started from. So what we're going to look for is to see if those patterns happen. So the first thing I look for First of all, this has 3 terms. It's got a b here, so it can't be conjugates, but it might be, the factors might be perfect squares. So here's what we'll look for. Is that a perfect square? And is that a perfect square? That's our first 2 steps. So the square root of 49x squared, 7x. Square root of 9 is 3. So those are both perfect squares. So for now, this is looking good. The next step that we have to do, just to verify, is we're going to take the 7 and the 3, multiply those together. That's 21. But then we also want to multiply that times 2 and see if we get the middle term. And in this case we do, meaning this is in fact the product of perfect squares. So we have 7x plus 3, 7x plus 3. And those are our factors. Now we could take this a step further and solve. Now, unlike some of the other examples we've done, we only need to solve this once because it's the same thing. We're going to get the same answer twice. So minus 3, 7x equals negative 3, divide by 7, and x is negative 3/7. A lot less work than if we factor this out the way we have been. But again, it only works in this one specific scenario. All right, so now we're just going to look at a different type of example. This one's a little different because we actually have 2 variables. But the same thing can occur even when we have 2 variables. So I'm going to look here. I notice that that's a perfect square, 6a. I notice that this is a perfect square, 5b. Next thing we need to do is check the middle term. 6 times 5 is 30, and 30 times 2 is 60. So this does check out. It is the product of perfect squares. So we have 6a plus 5b and 6a plus 5b. Now solving this one would be a little different because we have 2 variables, so we can't really find one answer, like one number that this is equal to or the solution is, but we can solve it in terms of one of the other variables. So, for example, we could solve this in terms of a. So what would that mean and how would we do that? Well, that just simply means that we're going to solve it for a. So we take that 6a plus 5b and we get a by itself. So equals 0 minus 5b minus 5b. Let me erase some of this, give ourselves some more room. So that cancels. It'll work this way. 6a equals negative 5b. Divide by 6, divide by 6. Negative 5b over 6. All right, so now we're going to look at some examples that will end up being conjugates. So for this one, again, the alarm that we need to be looking for, what kind of sets off, oh, this might be conjugates, is that it's missing that middle term. We have our a term, and we have the c term. Also, more importantly, this is a perfect square, and so is this. Square root of 49x, 7x. Square root of 81 is 9. And the way that we do this, conjugates, remember, one of them will be plus, and one of them will be minus. And now we could just solve both of these and get our solutions. 7x plus 9 equals 0. 7x minus 9 equals 0. So 7x equals negative 9. 7x equals positive 9. Divide by 7, divide by 7, divide by 7, divide by 7. And we have negative 9/7 and positive 9/7. And these will generally end up being opposites of each other because that's what's happening here. They're opposites of each other. All right, so we're just going to look at a couple more examples, some kind of different things that you might see that could occur dealing with conjugates or perfect squares. So in this one, we're looking at an example that has 2 variables. Same thing with perfect squares. We can do it the exact same process. It only has 2 terms. We're subtracting, and both of those terms are perfect squares. So the square root of 25x squared is 5x. The square root of 100y squared is 10y. So this will just be 5x plus 10y 5x minus 10y. And like the example of perfect squares that we did that had two variables, we could solve this in terms of one of the variables, but that's as far as we could take it. All right, last one. This is probably one of the more difficult of the ones that we've looked at because you have to look a little deeper. This example, that's not a perfect square. That's not a perfect square. And actually, they both have x, and they're different degrees. Now, being that they both have the same variable and they have different degrees, that's kind of one of the things I'm looking for. What we can do is we can factor something out of this first. So they're both divisible by x squared, so we could factor that out. But they're also both divisible by 2. So I'm going to factor out a 2x squared before we do anything. 32x to the fourth divided by 2x squared is 16x squared. And negative 50x squared divided by 2x squared is negative 25. So what we've done now is we've turned this into the product of conjugates. So we can leave this alone for now. We'll get back to that later. So 2x squared, square root of that is 4x. Square root of this is 5, so we have plus 5, 4x minus 5. And there's our factors. So we could now solve this. Difference now is we just have 3 places that we need to set up and solve equations. So we're not going to work all these out, but we would just do 2x squared equals 0. So we would do 2x squared equals 0. That would give us solutions. 4x plus 5 equals 0. There's another solution. And 4x minus 5 equals 0. These 3 places are going to give us the solutions.